Welcome to day 3 of Industrial Ethernet Week. We are so excited that you're with us today. It's been quite a week when we've covered a lot, from the trends that we've seen in the market and how they've shaped what we're using, and what we see, and especially in the manufacturing environment, how customers are adapting industrial Ethernet technology and how it's shaping their digitalization initiatives. Yesterday, we spent time on shaping the product roadmap and what are the products that are out there that enable industrial Ethernet, and what new technologies are in the market to help that we need to be incorporating into our roadmaps and to our customers' roadmaps. If you were unable to attend those sessions, it's okay. We have them already available on LinkedIn, and if you've registered for this event, you'll be getting an email afterwards with links to both yesterday and the day before, and also from today's event. But before we start, let me just cover where we're headed today. Today is all about the future of industrial Ethernet with single-pair Ethernet. Again, if you have not heard about this exciting new technology, please stay tuned. We're very excited to show where this is going. We'll be talking a little bit about how the standards have developed over the past year and where we sit today. And we'll be hosting a panel discussion with industry experts on what the customers are actually using single-pair Ethernet today, and what are their successes, and what's their feedback on the technology. What will be the need? What do we need to do to encourage mass adoption of the technology? And at the end, we're so excited to show a demonstration of the technology in action. So please stay tuned. It's going to be an exciting day. So with that, I'm going to turn it over to Mackenzie Reed. Thank you very much.
Thank you, Lucas. My name is Mackenzie Reed. I am a technology manager for standards development here at Harding. What that means is that I'm mostly dedicated to single-pair Ethernet development within our organization at Harding. Today, I'm going to be talking about the T1 industrial connector, which is also called the IEC 63171-6 that you see there behind me, and I'll be giving an update around where the standards are at this time. So what is single-pair Ethernet? If you joined yesterday, my colleague Arnold gave a brief walkthrough that I'm going to reinforce today. Firstly, single-pair Ethernet is not just a connectivity change. Harding is the connectivity leader in the industrial and Ethernet space, but there's a little bit more that goes into SPE than just swapping out the connector from, say, an RJ45 to the new T1 industrial connector. It requires semiconductors, magnetic chips, new SPE-rated cable, obviously the connectors that we'll be talking about here today, and test and measurement devices that are already hitting the market to certify single-pair Ethernet connections. How is this different from the Ethernet that's come before? If you're familiar with Ethernet, the common term of fast Ethernet in the market is 4 total wires, 2 twisted pairs, where one twisted pair was doing transmit and the other one was doing receiving. This typically was rated up to 100 megabit per second. And then the market advanced to gigabit Ethernet speeds with bidirectional communication, where each twisted pair was doing transmit and receive across 8 total wires, or 4 twisted pairs. And you can see up to 2.5 gigabit speed there. Single-pair Ethernet is exactly what it sounds like. It is a single twisted pair doing transmit and receive simultaneously at speeds starting from 10 megabit per second all the way into gigabit and eventually multi-gigabit speeds. This is what the industrial Ethernet landscape looks like today, especially as we talk about industrial automation and machinery. At the top, you have the cloud-based level. This is data storage, whether that's on-site or remote. The next level being supervisory control. That's where the technicians are monitoring, say, an entire field application from one central control room if they're doing centralized control. The next area being the control and PLC level. And these 3 have already been adopting single-pair Ethernet technology up to this day. The disruptive area of the market is going to come at this bottom layer, which is the field devices. This is what we're all very excited about. The buzz definitely has been around 10 megabit per second speeds. If you're familiar with Ethernet in your personal lives or in an industrial setting, 10 megabit doesn't sound like a lot. But for this individual level, the individual sensor that's mounted on a piece of machinery that's out in the field, this is unlocking an entire new host of capabilities for those devices. We imagine the automation landscape to transition into something that looks like this, where we're not necessarily saying that sensors are going to be talking directly to the cloud, but that they will have that capability because of the advent of single-pair Ethernet. All devices from top level down will be on a common industrial network. The sensors and the field devices able to talk to each other, make real-time decisions. And in my opinion, I think that SPE will bring IIoT, or the industrial Internet of Things, into reality, since we've been talking about it for the last 10 to 15 years. There are a few different types of SPE. If you're familiar with single-pair Ethernet, it can get confusing. If you're not familiar with single-pair Ethernet, these different types can especially get confusing, so I want to touch on them very briefly. APL stands for Advanced Physical Layer. This is mostly going to be for process automation applications where the main design criteria of that standard was around intrinsic safety for harsh environments. The next is what's called resource-constrained in-cabinet devices, or it's commonly called multi-drop solutions. So this is where you will have one common bus or line, and you'll have drops coming off of that that's facilitated by single-pair Ethernet technology. Point-to-point general purpose SPE is what we're mostly going to be talking about today. That's where you have one input and one output. It's the same connector on both sides of the cable, and it's device to device. And we're going to be showing some examples of that. And finally, we'll be showing an example of the hybrid portfolio, what's out now, what's coming next, and it'll actually be a part of one of the two demos that we're doing today. So from a standards point, we get this question a lot, or is what has been done, what's coming next, when should I expect standards to come out? All of the organizations that you see here behind me are actively working on single-pair Ethernet standards at this time. There are others, that frankly just don't fit onto our 30-foot screen because that's how much investment and development is going on in single-pair Ethernet today. Myself personally, being dedicated towards single-pair Ethernet standards, we are really, at a point where it's the same people sitting in all of these different global organizations trying to do what's best for the market as we, if you joined yesterday where we were talking about some of the issues that are going on in the market, we're expected to produce more with less people at a lower cost in smaller devices. These standards organizations are trying to accomplish that by writing very distinct rules of how to use single-pair Ethernet technology. So why SPE? A couple of the talking points here, as I said, in my opinion, I think it's going to kick off IIoT in a real way. We have an increased need for automation because of general manpower shortages and the loss of, some critical knowledge skills as an entire generation of people retire. The rising demand for decentralization and modular machinery. Maybe what works in your industrial plant today is not going to work for you in 5 years, and you're going to need to reconfigure, and this will help you do that. And finally, as I just said, everything, we're trying to reduce costs, increase functionality, and reduce the overall size while also making it rugged and industrial. And, once you take a look at the single-pair Ethernet connectivity products that we have, you can see that they're definitely miniature. So before even SPE came about, depending on what devices you're talking about, what components you're talking about, SPE devices are just hitting the market in the last couple of years. We've seen a natural shift in the market in the last 6 to 7 years from bus-based technology to industrial Ethernet technology. So this was the landscape. You can see that especially field bus type devices dominated the market, and this is what it looks like today. You can see a complete reversal of what people are doing. When they're bringing new nodes online, when they're designing new systems, and when they're designing new portfolio of products, largely they're moving towards industrial Ethernet as their connectivity solution of the future. And this has been independent of single-pair Ethernet. As I just said, these products are just hitting the market now. So this was happening before SPE, is entering the plant floors and entering these industrial environments. So we expect this trend to continue. And this is the T1 Industrial, again, called 63171-6. That is its IEC designation, but you can see here that we'll be talking about general purpose point-to-point connections today. So one device connected to one device, or maybe utilizing a managed or unmanaged Ethernet switch to talk to a host of different devices. This is what the family of products looks like today, with many of these either already being available or hitting the market this year. But moving from the far side over to the side that I'm on here, Starting at IP20, we have a few different options, and then as you move all the way over to here, this is the IP67 version. And the most important thing to realize here is that no matter which connector I'm talking about, no matter which connector we show today, it has a common industrial interface at the center. It has that same common rectangular portion, whether I'm talking about the IP20 version or I'm talking about the IP67 version. And this is the overwhelming reason why many standards are adopting single pair Ethernet is because in a plant floor application, let's say they need IP67 rated connectors, but that device needs maintenance. They're able to come with the more common IP20 version, plug in, do what they need to do, and replace the field rated cable. These are some of the standards organizations that have already recognized single pair Ethernet technology, namely being IEEE 802.3CG, but also 3 working groups within TIA and also IEC SC25 Working Group 3. So quickly on SPE hybrid, how is that different from the T1 industrial connector that I just showed you? It still falls under that -6 designation that you see up there, but if you look at it, you can see that there are some differences, namely that it has 2 more pins. That's because what we're able to do is break out power. SPE is able to provide data and power over what's called power over data line or single pair power over Ethernet. This is when your power needs when you require more out of that than what the T1 industrial or what PODL can do. So you break out power, it's independent, but it's still inside one form factor and it's still inside one connector. So it's an industrial rated connector and you don't necessarily have to use a compatible chip to handle your communication and your power. You're able to design that on the board as 2 separate things using one common connector. This is the upcoming new version of the hybrid connector. It's going to be the M12 form factor. There will be 2 versions of it. What you can see here is the -6, but there is also a 63171-7, which has consensus in the entire market. All manufacturers are very excited about the -7 connector in the M12 form factor. And why hybrid versus T1? I covered much of this, but it's PODL or SPOE is an emerging technology. Sometimes your power requirements are above what PODL can do, which is about 50 watts, which has been tested today. When you use hybrid, you're able to do 200 watts, and we've even exceeded that in some of our own testing. And finally, you're able to daisy chain these solutions, and we'll be showing a little bit of that during the demo presentation later. So now I'm going to hand it off to my colleague, Frank Wetzel, that's going to give an update of the SPE Industrial Partner Network, which Harding is proud to be a founding member of.
Thank you very much. So thanks very much for the overview. Very, very nice to see where we are at the moment. A warm welcome from my side as well. I would like to introduce myself. My name is Frank Wetzel, and on one hand, I'm a member of the Harding family. So I'm working for Harding, and I'm responsible for the global product management for device connectivity. So any kind of connectors is in my responsibility inside the device and at the device. But today I would like to talk a little bit more to you in my function as a president of the SPE Industrial Partner Network, what we have founded. But let's start with a short look back. End of 2015, we started in Harding to notice that there is a change in the infrastructure for automation. What we see is there is a trend in automotive, of course, for single pair Ethernet, and is very well established in automotive industry. And what we noticed is that there will be a trend that also the single pair Ethernet technology will come to the industrial market. And so that was the founding idea for us to say, okay, let's talk about the issues, what can happen in the future. And that is something what we took into account, and we ask ourselves, what is necessary to make this technology really as a success story? On one hand, of course, there is a topic of standardization that started end of 2015. So during all the years until 2015, until now, we had a lot of discussions in standardization, what you have seen by the presentation from McKenzie. But some years later, we ask ourselves the question, what is needed to make really a big success story out of single pair Ethernet? And of course, that is not only connectivity. We need to have much more. And that's exactly the reason why we founded the association together with some partners. So we went out to find partners to make a foundation out of this technology. So we founded the association, what is called SPE, Industrial Partner Network. It is based on German law, and in our point of view, it is absolutely necessary, because if you think single per Ethernet bigger than just connectivity or some single components, therefore you need partners. We believe that there is no company in the world who is able to establish such kind of technology only by one company. So you need partnership, you need different technologies, you need to bring technologies together. And that's exactly the target what we have defined for our association. So our idea for the association was to bring together very strong brands, very strong technology partners to increase the possibilities for single per Ethernet. The key idea, of course, is not just to present what single per Ethernet is. The idea, of course, is we want to make it possible to use single per Ethernet, and we want to become a kind of marketing platform to help the user, the end user, to use single per Ethernet in their application. That is something what we try to do. And of course, we want to make it possible to, we want to make it transparent what kind of application you can cover with single per Ethernet. That was the main idea for the founding of this association. And where we are today, and let's start with the commitments what we have today. On one hand, we have a registered association based on German law. Why we did that? It's quite simple. We want to have an alignment between all our members, an alignment and a common target what we want to work for. That's a key why we said we need a kind of contract between all our partners to bring the idea of single per Ethernet really on the next level. After that, we say what is needed to become really successful with single per Ethernet. We need a commitment for a common global infrastructure. Of course, in Ethernet in general, based on RJ45, you know that. But also for single per Ethernet, it is necessary to have one common interface at the end of the day to make it possible that all the different devices are compatible to each other. And that is something what we have aligned also with all of our members. And to think single per Ethernet bigger, we say we need to have a complete ecosystem. It makes no sense to talk only about components, makes no sense to talk only about devices. We have to have the whole interface structure or the whole SPE structure into account. And that is something what we did also in our direction. And last but not least, of course, we want to show the user of single per Ethernet technology what kind of applications are possible. Let's have a look to the members where we are at the moment. So our network, we started with 7 founding members, and that is something what is necessary to found an association based on German law. But today we are very proud to have more than 60 members on board. And if you have a look to these members, you see a lot of really, really huge brands with a complete different kind of competencies in place. So we have device manufacturers on board, we have component manufacturers on board, we have consultants on board, search protection devices, so every test equipment, everything what you need for Ethernet applications or for a kind of ecosystem, we have on board. And for us, it is also very important to influence the possibilities with single per Ethernet. You have to have a global footprint. So we don't want to focus only on Europe. We want to focus on Europe, Asia, and of course also Americas. So at the end of the day, single per Ethernet is something for the whole world. And that's the idea what we are following here with our partner network. Let's talk a little bit about the idea of this association. I talked to you that we think in a big ecosystem. What does it mean, this kind of ecosystem? And by the way, all the partners what you have seen are aligned with this ecosystem. So all of them are committed to take care that this ecosystem will grow. Let's explain the idea of the ecosystem. On one hand, of course, we have the basic technology, what you can see in the middle, the SPE technology in general. That is something what is needed, of course. The next step, what we need also, is a global standardization, what needs to be in place, and that is something what Mackenzie told you. It is in place so far. And the next step, of course, is you also need the components. So based on the technology, based on the standards, you need components to realize devices. And that is something what we did as well. And all our partners, what we have on board today, try to have a clear placement in this ecosystem. For example, we as Harting, we do the patch cords, we do the cablings, we do the connectors, and of course some devices like switches we have in our portfolio as well. And if you take all the other brands into account, we cover all these different areas of this ecosystem. And that's the basic idea why we say we need a common commitment to this ecosystem. And we have it in place. Next step is the topic of standardization. As Mackenzie mentioned in the presentation before, there are many standards in place, but the key point in our point of view is the commitment and the alignment and the interlocking between the product-oriented standardization and the application-oriented standardization. And if you have a look to different areas of standardization, sometimes we facing really the trouble that the product standards doesn't fit together with the application-oriented standards. Sometimes we have this. In single pair Ethernet, we did it in a complete different way. So all these topics, what we have in place, are aligned with each other. On one hand, of course, this IEEE standard is a basic technology, what is written. You can see here over there. It's a basic technology, of course, that's clear. It's completely standardized. We also have these standards for cabling in place, what are driven also by our partners from the network. We have also the connector standardization in place. So the products and component standards are in place by 100%. And now the key point for us, and that's in our point of view, is the biggest benefit what we have reached for single pair Ethernet together with our network is also the application-oriented standards. We have 100% aligned with the product standards. So in our point of view, an important bridge between product standardization and installation standardization. Let's have a look how it looks like. Maybe it's a little bit too small to read, but the key point is what Mackenzie also mentioned is we have this /6 standard in place where all these different connectors are defined so far. So for all kind of application in this standard, you will find everything what you need on one hand to produce the standard, on the other hand to make use of the product and to make use of the products. So all this stuff is defined in this one standard. If it comes to the next step, and that is something what Mackenzie also mentioned, there is a new standard in place as well because this /6 standard has a hybrid solution for M8 connector in place. But one product was missing, and that was the M12 hybrid connector. And that is something what we do in a separate standardization here as a /7. But this product is also in line with the strategy of our network. So all the product standards are done now. Let's have a look to the installation part. In this IEC standard, what you can see over there, it is a generic cabling of customer premises, so industrial areas. So whenever customer want to use single pair Ethernet and want to make an installation based on the standards what are on a global base in place, he has to follow the connector structure, what you can see here, the connector what comes from the /6 standardization. This is the first alignment between installation, so cabling installation standard, and product standard. The same we have in TIA, of course, what is very important for United States and for Americas in general. We have the same. This is just a copy from the standard. So you can see here, it also refers to the /6 standard, product standard. So also for the TIA applications, if you want to make an installation in line with TIA, you have to use the /6 connector. This paper is also ready. It's very close to be published. I think we expect it in summer. I would say early summer is the expected time for the publishing. If we look to another standard, if we talk about the building installation or in general the installation of cable systems in industrial areas, we also have one additional part, what is so-called the automation island. So if you make a special automation island based on the IEC standard and you want to install it, we have the same in place. Also, this installation standard refers to the /6 standard. So all the product-oriented requirements are in there as well. So we have one common standard, what is referred by all the installation standards what we have in place now. And if we look to IEEE, in most cases IEEE do not give any ideas what kind of connector you have to use, because they are focusing, of course, with the transmission protocol to many different applications. But in that case here, due to the fact that there was a global voting for the /6 connector for industrial areas for single pair Ethernet, the IEEE decided as well to make a recommendation in the direction of connectors. So also in the IEEE, and that's really unusual normally, also there is a clear statement, maybe use the /6 connectors if you install single pair Ethernet in industrial applications. So in our point of view, that is really an important basement for us as an association, because it's really as a basement for all the investments, what a device manufacturer, for example, is doing or will do, is there is one common standard in place, and the alignment between the standard, product standard and application standard is in place. So that is really, that ensures that he invests in the right direction. That's very important in our point of view for device manufacturers. The question what rised up since many times is always a question, what is available for single pair Ethernet so far? What kind of components are available? What kind of cables are available? What kind of components like magnetics are available? What kind of connectors are available at the market? And also what kind of devices are available? That is a question what rises up in every call what we have with customers or what we have with other associations. Whenever we had this discussion, always this question rises up, what is available now? And that was reason enough for us as an association to say, let's create a database. And it's absolutely unique in the world so far. So whenever you are looking for a component or for a device or whatever you want to have for single pair Ethernet, this is the point where you can look at. All kind of products what are available so far, and at the moment we are talking about around about 500 products what are in this database. You will find all the information what you need in this database. So very easy access to you. If you go to the website, you can sign in, you can type in your address, of course, and after this login, you have the possibility to have access to all this information. That, of course, was really a long way for us. We collected a lot of data. We bring a lot of data with our partners in this database. And that, of course, is something where we believe it's very helpful for you as a user and to give you an overview what is really possible with single pair Ethernet so far. Let's summarize. All the partners, and once again, we are talking about 60 very well-known technology companies in the world, what are part of our network. All these partners are aligned to the standardization of the -6 and -7 connectivity. So what does it mean at the end of the day? There is one global infrastructure available for single pair Ethernet. And all these partners helps us and helps you, of course, to make single pair Ethernet really as a next door opener for new applications. And single pair Ethernet, in our point of view, is really a game changer. And all these companies, what you can see over there, are committed to this game changer and also committed to make this game changer really to a success story. So that should be a short overview about the SP Industrial Partner Network. And of course, I'm looking forward to the panel discussion with some additional guests, of course. And please keep with us for a few seconds. Now it's time for a short break, and the panel discussion will start in a few minutes.
And welcome back. Thank you for staying with us for this exciting panel discussion. Again, I'm Mackenzie Reed, and I'm going to be moderating this panel. I am from Harding, and I'm going to introduce my colleagues here for this panel discussion, then let them introduce themselves fully. You can see one of our colleagues here, Brian, is joining us remotely from Ireland. And then we are happy to have Dale here in person, as well as Frank rejoining us. So Brian, why don't you kick it off and let us know, where you're from and what ADI is doing.
Thank you, Mackenzie. Hello, I'm the Director of System Design Engineering at ADI in the Industrial Connectivity and Control Division. I've been working in Ethernet as a PHY architect and system architect for over 25 years. Come from 10BASE-T, 100BASE-TX to 1 gigabit Ethernet, and now in single pair Ethernet and 10BASE-T1L. So we've seen that transition from 10 to 100 to 1,000 in the home office, in the local area network, and we're now in the same journey in industrial Ethernet.
Great, thanks. And just quickly going through, you know, we want to first establish who we are, what our organizations are doing, and how we're addressing single pair Ethernet today. But before you get to, you know, some more of the slide content, I want to give Dale an opportunity to introduce himself.
Hi, I'm Dale Chalky, and I'm a field application engineer for Aero Electronics out of the Chicago market. And I'm involved with the single pair Ethernet deployment. And we have a number of suppliers on our line card. And what we do is we gather up those solutions and offer reference platforms for customers that want to get started into this using this market-leading technology. So look forward to working with some of the customers in the very short term.
And then again, we have Frank rejoining us on behalf of the SP Industrial Partner Network. So Brian, feel free to take it away and just kind of walk us through, you know, why industrial Ethernet connectivity from the ADI perspective.
Sure. So ADI has been a very early and strong proponent of single pair Ethernet. We presented the call for interest at the IEEE as part of the development of the single pair Ethernet 10-base T1L standard, and contributed quite significantly to that development. We engaged very early with customers in parallel with that standard development with prototype products to, you know, really start to understand the early requirements there in that market, and to really try and evangelize and kind of really help this market start. You know, an obvious question is why industrial Ethernet? Why industrial Ethernet connectivity? It's the benefit of using the same basic frame throughout the network. You know, interoperability, deterministic real-time performance, standard-based solutions, and that scalability from 10 meg to 10 gig. Every customer you engage with, you know, sometimes is about the cable, the power, the connectivity, all those issues, how to do it. But the one common theme that comes back every time, why are they interested in this, is they want to transition to Ethernet. It's that huge advantage of that same basic frame format that's huge. So what ADI have been doing to support this market is, as soon as the standard was published, you know, we provided a full set of PHY, MAC-PHY, 2-port 10-base T1L products, and single pair power of Ethernet products, you know, to enable this market. We're providing that semiconductor components in all those key areas to help drive this forward.
You know, just kind of moving into this, we covered a bit of how single pair especially is different from traditional or 8-wire Ethernet, but, you know, from your perspective, what are some of the questions that you get? And, you know, I want you to kind of talk through some of this content that's up here on the screen around how you address that question, or what the differences are from your perspective.
Yeah, well, the key one there is just on the left-hand side. What is single pair Ethernet? You know, we're all familiar with in our office or home, you know, the Cat5 cable, the RJ45 connector you plug in. You know, single pair Ethernet, it's early adoption, particularly in the process automation, where it goes 1,000 meters. You know, it's quite a different type of cable, and it's been adopted quite quickly because that field bus cable was there. It's the same basic cable, but it delivers power. It goes 1,000 meters. How else do you go 1,000 meters? You know, there's nothing out there in Ethernet today over copper cable, and will get you close to that. So that's really helped that market to start very, very early. You know, on the right-hand side, there's details there. We can go about signaling and pairs and power and all that. But really, it's the cabling. It's a long reach in the cabling. That's the key. And if you look at the next slide, it's what's the key. We talked, Frank talked about, you know, the field bus devices, that bottom layer connectivity. The key to edge connectivity is long reach. It's that seamless connectivity, the IP addressability for security, and that lower cost of ownership. You know, they're key factors that's driving this transition into single pair Ethernet.
Yeah, absolutely. One of the things I didn't talk about during the discussion was, you know, cabling was one of the benchmarks that I introduced at the beginning of the presentation, but there is an application use case for reusing field cable that's already been installed. And as we were discussing yesterday in the panel discussion, from an agriculture perspective, we have to support legacy systems. And if we can convert them, that's even better. You know, there's definitely best practices around using SP rated cable from the cable manufacturers that's hitting the market now. But we also have to be realistic of there's a lot of infrastructure that's been installed up to this point that we can reuse with this technology. So I want to now hand it over to Dale to kind of talk through, now we've heard from ADI from their perspective. Dale, to add on to that, what are you doing to address this market, as of today?
Yeah, at Arrow, we have a team of field application engineers that have certain expertises, and one of those areas would be single pair Ethernet. And Arrow would like to work with the broad market customers. That we've heard a lot about the industrial customers, but I get to service a whole range of different types of industries in my market. And I really find that single pair Ethernet with the data and the power being provided over one twisted pair interface is going to be very popular. It's going to lower the cost points, and it's going to shrink the footprint of the products of the OEMs and stuff. So what Arrow is showing on the screen here is we come out with a reference platform that's open source, and it's up on GitHub. You can buy the actual little blue box that's shown on the screen here from arrow.com, and it will allow you to get started with the media adapter converter box. And if you like what the functionality is, you can copy the open source software and hardware and incorporate that into your designs. Also, I brought up this little example today. You can see these two blue boxes are connected together with the yellow single twisted pair here. So that's an example of making a media converter. Or you can extend your got a couple RJ45 connectors that you can plug into this box here, and then you can get with your yellow wire there, you could put 1,000 meters in there. So you can go from your traditional Ethernet into a T1L today, utilizing this little media adapter box. And there's really not a lot of software that runs inside of these boxes, so it makes it quick time market to deploy. And in some applications, one of these boxes could be putting some sensors or motor control or camera systems inside of there. And with today's microcontrollers that are Ethernet based, you can then take those older applications and convert them into TL1 or T1L infrastructure. So
largely, I think that's where we're at today, is that we're in the testing and development stage of this technology. So, we were very excited to participate in that. You can see another version of it up here on the screen with like kind of a top-down view, as well as a little bit of what it looks like inside the blue shell. This is definitely a development kit. And we're going to see a different version of that towards the end of today with one of our live demonstrations. But we are, especially here, we do these panel discussions. We have these partners that are joining us today because we want to address the development needs of the market. A lot of OEMs have devices, I showed the automation pyramid at the beginning, that are currently running on Ethernet, and they want to start playing with single pair Ethernet technology, and this bridges that gap. It allows you to begin your process of testing and developing your next generation devices. Whether you're an established legacy industrial OEM, we talk a lot about automation, but you're seeing it in other markets, or if you're an emerging company that has a novel technology that's coming online for the first time, devices and development kits like this get you started, and really that's where we're at. Yeah. Arnold shared yesterday that there's a curve of adoption, and one of our other products, the IX Industrial, is in the next stage of that. Single pair Ethernet is at the very first stage of that adoption curve. It's the bleeding edge technology of this. So yeah, we're very excited about it. Frank, did you want to touch on that?
Yeah, I can remember the first discussion what we had is around about two and a half years ago, I would say. Yeah. We talked about such kind of presenter modules, what we can make together. And maybe that's also the reason why the Harting connector is in, because we very early started the discussion. And I remember also last year we did a lot of common marketing activities in this direction to bring really to place Ethernet, a single pair Ethernet to the market. But it's underlined exactly what we as an association always also want to do. We have defined our new strategy for the next 2 years. And the key point is really to make it touchable. So to create such kind of samples, how we can show the customer, the user of single pair Ethernet, hey, what is really possible? And that is something what we do in collaboration. And this is a beautiful example in my point of view. Another example, for example, is what we have shown during the SPS last year. We did it together with one of our partner, Hirschmann, Hirschmann Belden, who had a nice switch in place as well. And we make a kind of presentation what is really possible today with Ethernet. And we have a Harting switch on our booth, and Belden has a Hirschmann switch on his booth, and we make a transmission from pictures from Belden booth to Harting booth and the other way around via single pair Ethernet, and that works really fine. And the direction for this, why we do this and why we want to create this test use cases, is really easy. We can show really that it works, and that's a key point in my point of view to bring single pair Ethernet to the next level. And what it was really interesting to see how enthusiastic also the partners and all the visitors were. Hey, that's really single pair Ethernet. It works amazing. What is the distance? Was a question. And we say, yeah, normally it is written as a standard. It's 40 meter only, and we did a transmission line what goes up to 60 or 58 meters on this booth, and it works without any problems. Yeah. So it really a nice impression there.
Yeah. I mean, I shared a little bit earlier, but we've definitely internally and with our partners, you know, whether that's Brian joining remotely or any of us here in the room, we've tested the limits of those standards. And there are projects in place that haven't maybe kicked off yet, but there's a full understanding that this technology can do more. You know, Brian, I think that you've actually tested far beyond 1,000 meters with some of your products. Do you want to speak to that, you know, at all?
Yeah, I mean, the technology goes the whole way out to 2,000 meters on that. So, I mean, there's a huge amount of robustness built in. This is a standard designed for industrial Ethernet, designed for very, very noisy environments, designed from the bottom up. I would say if you want to put it in the noisy environment, putting it at the extremes, you're probably somewhere like 1,500, 1,600 meters. You know, that 2,000 meters or even beyond is, you know, in a quieter environment. But it shows a huge robustness we have built in here to deal with these very, very harsh environments.
Yeah, it's very exciting. Yeah. So we've kind of touched on what is happening today. Another thing that we wanted to talk about, we admittedly where we focus a lot on industrial automation, process automation, and a lot of machinery applications. But you know, Dale, we'll kick it off with you. What are some of the different application use cases that you get asked for from like the channel and distribution standpoint?
Camera systems that need to, you know, be powered over the, you know, single twisted pair and long distances.
Yeah.
So we're seeing security camera conversion from analog to digital.
And is that at like gigabit speed, or are they able to do 100 megabit?
100 megabits.
Okay.
Yeah, definitely would play well in that performance. And sensors, motor control would be other key areas that we're kind of getting some interest. So
yeah, I mean, we were talking about it yesterday with our panelists from the AEF committee. They're heavily focused on single pair Ethernet for cameras on the tractors and the implements.
That's correct.
So you know that is not a traditional industrial automation application, but it is another good single pair Ethernet use case. Brian, do you want to share some of the feedback that you're getting from customers or application use cases that you're getting asked for?
Sure. In terms of the ones that are immediate, is clearly process industry because of that need to go 1,000 meters, and they were one of the kind of early proponents of it. And you talked about legacy cables. Well, the field bus cable is quite similar to what was defined in the standard. But some of the newer interesting areas are the likes into building technology and the control network, so connecting air conditioners. And there's a huge interest in how we bring this, because of the saving and the cabling, the connectors, the robustness, into building technology. And that's an area where we're seeing, you know, quite a few more challenges. There's a lot more there to figure out because the wiring topology is a lot more complicated. They don't always do point to point. They have a much greater mix of speeds. They don't necessarily have the need for intrinsic in there. So that's a market that I think is going to be very strong in time and very big, but it's going to take longer to develop, longer for us as an industry to figure out those problems and how do we help solve them. Dale talked about cameras. Even at the 10 megabit speeds, you can do a lot with video, and there's a lot of cases predicting cameras outdoors, cameras on freeways, where you're going much, much longer than 100 meters, and you're trying to connect to these cameras. So that long reach is hugely beneficial. And we are going to see, of course, future developments that will enable more of that.
Yeah, that's definitely true. We're seeing customers coming at us from our traditional target markets, as well as emerging markets that haven't traditionally been our direct focus of Ethernet products. It's really exciting. I want to share one, but Frank, I want to hear, what are you seeing from like the European standpoint or within the industrial partner network?
Yeah. So what we are facing very often is a question, what is ongoing with higher speeds, of course. On one hand, of course, we are talking about the 10 megabit, what fits in a lot of different applications. That's clear with a long reach. That's not an issue. What we also see is the topic between APL and the other 10 megabit applications in field applications, that it works very fine. I remember during our first our first event, what we did with the SP Industrial Partner Network, we invited from Peppel & Fuchs, Dr. Kegel. He's the president of the ZVEA and the CTO from Peppel & Fuchs. And he told a very interesting story. Together with the 10 megabit application, long reach, he told us he's 100% sure that during the next 10 years, 80% of all applications will be in touch with single per Ethernet in process industry.
Wow.
And that's, in my point of view, it's really clear and an amazing statement.
Yeah.
So I believe this is really one of the key drivers, the long reach activities, but on the other hand, also the higher speeds. For example, what I explained at our booth, of course, it's not the 10 megabit, it was 100 megabit. But what we see, especially in the discussions with automation islands, of course, we are talking very often about the 100 megabit applications. And that is something where we see a lot of requests coming from the market as well, up to 1 gigabit, of course. Yeah. That is something where we see that especially the machinery market, for example, will become more and more in this direction as well. So really close the gap between sensor and actor, also in machinery market. It's a huge opportunity as well for SP in general. Why? Because it makes it also easy to install. I don't know if you have ever tried an 8-pole RG45 to install it in a dark environment,
right.
with bad light conditions.
Yeah.
It was amazing. In the past, I did so many mistakes that I installed that. I came from the installer side as well in my past, many years ago. And I think single per Ethernet makes it so easy, makes the use of Ethernet to the edge really simple, also for its installation issues. So
yeah,
something we should take into account as well.
Agreed. And we're seeing very interesting questions coming from the different markets depending on what their critical needs are. A little bit before I go further, I forgot to say it at the beginning, but if any of this you want us to dig into more, feel free to ask questions. We're going to address those at the end of the panel discussion. We already have some questions that have come in either when I was presenting or when Frank was, but if this is generating ideas and questions from you, please ask them and we're going to address them. One of the things that we're seeing from one of our traditional markets is that board density has been their most critical design constraint for single pair Ethernet. So we've gotten questions of how are you going to address multiple channels on a board, and is that a T1 industrial type of situation, or like how are you going to try and just pack more functionality into this board that's already defined, and maybe they're trying to upgrade to SPE. So that's one of the questions. Another one is how do we integrate this into some of the most rugged connectors that Harding makes, within our HAN product line, our HAN family of products and Harding customized solutions, very large industrial cables that are rated for some of our most harsh environment markets. How are we going to do that? We need triple redundancy. We need guarantees that the system is never going to go down. So these are all the questions that we're addressing pretty much on a daily basis, both from our key account customers as well as new customers that we've never interfaced with before this time. So with that in mind, across our different organizations, how are we going to help facilitate mass adoption of this technology within the both the product lines that we have now and, you know, what you're currently carrying from the Aero perspective, and how are we going to help kind of shepherd this technology forward, you know, as we get these application use case questions. Brian, feel free to start.
Sure. Well, I mean, one thing that is going to drive this is greater integration, greater speeds. One immediate challenge we see, we have an Ethernet, we've gone from 20, 30 years ago, 10 megabit speeds, 100 megabit speeds, to gigabit speeds, 10 gig speeds. All the 5 switches went to multi-port, huge amount of integration. So one challenge we see our customers finding now is finding a 10 megabit switch to go back with this 10 megabit speeds. Those components don't exist anymore. Yep. So that ecosystem is still going to be developed, and it is a touch of a chicken and egg. It's getting the market to adopt, to develop products to make it happen. But we're only seeing the first set of products out now. They will be followed by more integration that would enable some of that greater density. And the other one, of course, is going to follow is higher speeds on that. I mean, the whole rollout into process is knowing we needed 10 megabit to get to that edge. As that happens, you then need a trunk that can go at 100 megabit, not the same distance, but go much longer reach than we have today. And that will follow, and that will be developed. And I think that's going to, again, that confidence of the industry to know this is going to happen, you know, will kind of future-proof their investments today.
Sure. Yeah, Dale, any thoughts there to add on?
I just want to say, I think because of these technologies are standard-based in distribution, we're talking to broad market customers. Sure. So having the standards all in place, the connectors, the silicon all wrapped around this new technology, and there's software involved, right, that drives the engine of these solutions, which is already there based upon older traditional Ethernet. We're ready to go and support customers. So if you have an application that you would like us to check in with you on, we would love to come out and get you up and going. And we can definitely get customers with their applications moving along pretty rapidly with demos. And so we're not talking days, weeks, months. We're talking a number of hours, you know, to attach to a sensor or a motor or whatever the broad market application.
Right. You did that yourself, didn't you, with the media converter? You showed some photos.
So yeah, on this media converter, there's just a little $1-ish microcontroller in here, but you know, if customers got an application, maybe they got a microcontroller already. We just bridge that on the physical PHY devices in here and enable them to, you know, enhance their products with T1L interface. So everything's in place, ready to go. It's just we need to train our customers and introduce them to this technology and show them that they can get it done pretty rapidly. And another thing that I want to add is with what's exciting about this technology, everybody's got their smartphones and they've got the Internet of Things, and you want to log in and send your messaging, see what's going on remotely. Well, this is just an extension that, but it's copper based, and it's the lowest cost twisted pair deployment out there. So there's the great efficiency, and you're getting all those benefits, data and power all in one. So I see that this is really going to be probably a big breakout year for a lot of customers, you know, interested in, you know, incorporating.
Yeah, I think that's well put.
You mentioned the topic of training. In my point of view, training is one of the key points to establish a new technology like single pair Ethernet. And that is exactly something what we catched up as well, that the training process is the most important topic. So we have created as a network with all the competencies what we have on board, like Wirt Electronics and a lot of more. We have created a lot of use cases. And in our use case, you have an exactly declaration and explanation how, for example, you have to create a poodle, how you have to design the layout for magnetics, and all this stuff really very deep in detail described, because we believe that the topic of training is really the most important one. And of course, the level of training is a completely different one.
Sure.
On one hand, of course, you have the end user, where you have to train a little bit more the benefits and the possibilities for SPE. On the other hand, you have the designers, and especially for the designers, they want to have a detailed description, of course. And it's really a huge range of trainings we have to offer. And that is also something what we have defined as a target for us as a network to support you and, of course, the users as well, how they can realize devices with SPE technology.
And just kind of building off that as well, we're being approached for new applications, upgrades to existing applications. We've heard from, some of what the market feedback is telling us they need, but, I want to talk to each panelist about what they think the critical needs are today for this to be successful, mass adopted. If you even had to point it towards like one thing, Brian, we can start with you. What are the needs today, and how is ADI addressing those needs, like that our customers are finding most critical?
I think it's learning how to adopt the technology and seeing the huge benefit in robustness and simplicity of connectivity. That going from 4 pairs to 1 pair, you can't overemphasize how much that simplifies things. We can't get to less than 1 pair. So it's 1 pair at the highest speed and the most robustness. That, seeing those benefits, I think is really going to drive these markets in that. And it's really helping the customer to figure that out.
Sure. Yeah, we have to, in my opinion, we have to go above and beyond, maybe what our companies have traditionally done to provide more value to the customers, instructing them on this is what we do, but this is also what other people in the space are doing. That's kind of the point of today of what we're doing, is that this is an ecosystem, going back to the slide that Frank showed, kind of that half circle. At the center is the technology. One level out from that is the standard. The next level out from that are the individual components, whether it's the connectivity and cable assemblies, the PHY and silicon, like from the ADI products, whether it's the magnetics chip, a testing device, and who carries all this? It's our channel partners. They have a robust platform that's already available today to you, like we've shown with the media converter to get you started. So since we launched single pair Ethernet as a technology, and since we started launching products, we've continuously been pulled into conversations that don't necessarily have to do exclusively with connectors, but more so with the technology as a whole. So like I've had to grow my skill set of having knowledgeable conversations about, this is the PHY that you need to be considering. This is the type of rated cable that you should choose if you can't reuse cable in the field, those types of conversations. So Dale, what do you think?
So what I would think is the more we can get reference platforms, I know we can get platforms from the suppliers, and then, Arrow has an example where they kind of took a number of suppliers, put it down on a smaller footprint, but having different types of reference platforms to say, we're going to hit, security cameras or LED lighting or whatever could be coming out with the customers of interest and stuff. But what we'd like to do is come in, give them a reference platform of some form, and so they can take that, reshape that into their product and get it moving along, and do some potential end customer demos with a number of weeks. So super fast time to market play out. So that's what I think in distribution, bring in a single component here and there and just say, okay, go figure it out, is not going to help anybody. So,
right, exactly.
So we like to, work with the suppliers. They have big chunks of the solution. And then, of course, you got the hardware, and then you got software that you got to run. And sometimes, that's not always a consistent story as you see different platforms evolve and things of that nature. But yeah, bring in the solution to the customer and, go after their application in the fastest manner to bring it to market.
Sure. And Frank, from the Industrial Partner Network point of view, either within the technical working group or the marketing working group, which is how the organization is structured, what do you think in terms of critical needs?
I think the most important part now is we need the mindset for early adopters. Yeah, that is something what is, but of course, whenever you replace a new technology, you need the front runners. Yeah?
Sure.
That is something, of course, what we are try to find. For example, we know a lot of customers who make first prototypings with single piece to try what is possible. The second topic is also the maker scene. Maybe normally for us as an industrial network, maker scene is not really our target group normally. But in that case, we believe that a lot of ideas, what is really possible, comes also from these young engineers, and this is something what we would like to focus as well. So we need this open-minded people to make early adoptions for this technology, and in our point of view, that is really key to being successful. And of course, what we faced last year and the year before, of course, is a little bit the availability of components overall. What we also heard, a lot of our partners or also customers from Harting, as I know, did a lot of design-ins and prototypes, but then they faced the problem to take care for their cash cows. So they invested a lot of time in save their cash cow business instead of making new design-ins and making new prototyping.
Sure.
And that maybe is something what delays a little bit the early adoption of single pair Ethernet. But that is something what I think this topic is solved now, and I'm 100% sure this year and also next year a lot of devices will come to the market, and then it will speed up dramatically, I'm sure.
Yeah, absolutely. I think this has been great. We want to definitely make sure that we can hit as many of the questions that have come in as possible. I see the first one, Frank, it was when you were actually giving the presentation earlier around, the origins of SPE came out of automotive standards. Can you speak to that to some degree?
I'm not very deep involved in automotive industry
Sure.
because that's a different story for single pair Ethernet, but that of course is something where the technology is based on. So I cannot tell something about the standards what are in there, because our association said, okay, we have a clear differentiation. What is our focus? Mm-hmm. We don't want to touch automotive industry,
right?
Because a lot of established players, and I also heard from Broadcom, for example, they had around about 300 million nodes in place so far in automotive industry. Yeah. So that's really interesting. So we don't touch the automotive industry, and we also do not touch the building installation. We really have a clear focus for industrial applications. And so sorry for that, I cannot explain a little bit about.
Actually, Brian, if you have any feedback there about some of the automotive standards for SP silicon.
A simple comment on the reason is in automotive they're very, very sensitive to weight, the weight of the cables. So for them, that was a huge driver to get to a lighter, lower cost cable. And of course, they're also in a very, very noisy environment. I mean, no less or no more than industrial. They're two environments that are very, very harsh. So as a kind of a more cohesive group, they were able to drive that adoption, and they've much shorter reach. And they're operating what's effectively what we call a kind of an engineered solution. They make one set of cables and they repeat it 1 million times for a particular type of car. Where when we're working in industrial, it's got to be a standard based, there's N different ways of connecting these machines up, particularly in a building, everything's different. So the standard compliance is very, very important. But it did kind of start the way of showing it was possible to do this on single pair. And I think what industrial has done is it's followed with doing it at much longer reach. Building, I think, more from the ground up, particularly at 10 and 100. The T1 standard was really a small evolution of gigabit, where 1000 base T or 1000 T1 was from the ground up, but we're seeing 10, and I think the follow-ons in 100 base T1L will really be targeting what is needed in industrial and those harsh environments, latency, noise, connectivity.
Yeah, and I mean, from the standards perspective, the industrial standards definitely took a look at the automotive standards and used it as a foundation, and then said, what works for us and what doesn't work for us. Where do we need this to be more ruggedized? Which I think is where some of the connectivity standards came from, is needing more IP-rated connectors and a range of IP-rated connectors. Brian, kind of to your point, the automotive standards, my understanding of them is that they're low mix and very high volume, which is, I think, the kind of the way that you said it. It's the same application over and over. Whereas within industrial and process automation or agriculture or really any target market, there could be multiple different applications within the same plant,
absolutely,
within the same target customer group, and we have to be able to have the right connectivity solution. From the Harting perspective, you need to use the right connector for the right environment. I think in the past with some industrial Ethernet technology, that maybe wasn't the case, and that's why the standards are sitting within this topic for so long and defining these automation islands or defining the applications for IP20 or for IP65, 67, and making the best decisions that we can based on the information that we have today, based off that. So the next question, is we'll start it with Frank. Can you share within the Industrial Partner Network, we saw all the company images, but what's like the spread of the types of companies that are within the Industrial Partner Network?
If you look general to the global landscape, we have a lot of different members, of course, on board to have a really global footprint. And in our point of view, that's really interesting. Of course, we also maybe one background to the association. We do not have the target to collect as many brands as possible. That is not our target. So our setup is really to bring competencies on board to help us to support the ecosystem in general. And that's a little bit more our idea. And of course, therefore, the requirements from different areas in the world, of course, are different as well. And that's the reason why we want to have really technical competencies on board and customers who would like to drive the technology with a place in different areas of the world. Because what we also believe is that the requirements and the early adapter applications in the different areas of the world will be different. And that's the reason why we would like to have this global setup.
Great. If we could scroll a little bit, I see the beginning of the next question. Okay. Just give me one moment. So is it possible to design a media converter which utilizes the IO link type of connection and 10-base T1L / the IEC 63171-6 connector, which is the T1 industrial that we've been showing? I can kick this one off. Currently, where we're at from a standards organization is that the IO link technology is taking a look at single pair Ethernet technology and figuring out how to realistically integrate it into that, network. I guess that's the easiest way to say it maybe, is that they see the technology as viable. There's not a full understanding yet of how all of these things integrate together. And that's another area where we're currently at with this technology, I would say, is that these standards are coming out. If you look at the IEEE 802.3 standard, there's sub-standards within that, which is 10 megabit per second, 100 gigabit, and multi-gigabit eventually coming. What we haven't yet done is started to harmonize across all these different speeds and distances with devices that do everything. That's a point of active discussion within the standards organizations is, okay, we've outlined the minimum viable product or minimum viable standard. Now, how do we start harmonizing all of this so that it functionally works within an industrial environment? Because as we've talked about today, there's sensor applications, there's vision system applications, there's control level applications. Those all operate at different speeds and therefore are rated for different distances. So you need aggregation devices that pull all of this into one distribution cabinet or pull it all onto one network. And I would say that's kind of what we're handling right now.
Mackenzie, I would like to add something.
Sure.
Maybe you know that the IO Link has also an association. The IO Link Association is cooperating with the Profinet user organization in Germany. So what I know, because I'm a member of the advisory board of the Profinet user organization in Germany, there's a very close discussion that try to figure out what are really combinations between these technologies. So using the physical layer of single pair Ethernet and use it for IO Link. So that's something what is ongoing, and they have there is a strategy paper in place as well how they would like to position themselves in the combination with single pair Ethernet. So they do not use it see it as this or this. They try to figure out what is the common application part of the application.
Sure.
So that's ongoing, and it's a really strong discussion. And also our leader from our working group from the association, technical wise, is involved in these discussions.
Okay, the last question, then we have to transition to the demonstrations, which I'm equally excited about, is Frank, you talked about the database. Can you share a little bit more detail of the types of products that are available there? And then also, Dale, the types of products that are available from the channel portion.
Yeah. So if you look to the ecosystem, what I have shown in my presentation, all different kind of areas of this ecosystem. So if it comes to magnetics, if it comes to PHYs, if it comes to chips, if it comes to cables, if it comes to row cable materials, everything what you need for single pair Ethernet you can find there. So we have all the sections in our database, and of course it is increasing day by day, yeah? With new products, and all our partners can bring in their products, and also some of our cooperative partners like ADI, for example, we bring also the PHYs and chips in there. That's totally clear. And there is no limit so far. So also if there is a complete device available for single pair Ethernet, for example, coming from Peppel and Fuchs or Anderson House or whatever,
Sure.
we will bring it to this database as well. So it should be really a central point of information, a single point of truth for single pair Ethernet.
Yeah.
That's the idea.
Great.
Yeah.
So what I would like to do is typically meet with our customer, understand what they want to accomplish in their application. At Arrow, we have a line card of components,
Sure.
solutions. So which of those components, obviously ADI would be an anchor part and Harding with the connector. But when it comes to, do you need a gateway MCU that's got an Ethernet capability, MAC in it?
Sure.
What about transient protection? So it's really understanding where the customer is at with their thoughts and what they need to accomplish within their product that they're building, and then just give guidance. But start with the reference platform, grab as many pieces as you can reuse, and then add some changes and tweaks.
And I think that's the key word here that you just said is guidance. That we're trying to address our customers' questions, their concerns about like what this technology is and how it's going to affect their business and their product lines that exist today. And it's really at the center of the discussion is what are your needs? Like what are the critical points of your design, whether it be board density, speed and distance, IP rating. We have to go that step further. That's why the Industrial Partner Network was found. As Frank said, we're not able to do this alone. But we have to go into another level of detail, I think, that we maybe haven't done before with our customers, of fully understanding what they're doing and facilitating introductions, across the entire ecosystem of this is what you can come to expect from us, but these are the other components and pieces of the puzzle that you need to consider as part of your design and development. So I think that's kind of the perfect way to end the Q&A session. We're going to do another brief break. We're going to bring some live demonstrations out here. My colleague Arnold and I are going to walk through two separate application use cases, which kind of reinforce what we've talked about here. So just bear with us for a moment while we make that adjustment. Thanks. Welcome back. Before I dive right in, if you've been joining Industrial Ethernet Week earlier in our previous sessions, you know this man very well, but I want to give my colleague Arnold a chance to introduce himself before we jump into these demos.
Arnold Chenyewanji, within the product management team. I'm Senior Product Manager responsible for Industrial Ethernet Connectivity Solution here at Harding. A pleasure to be with you guys.
And so we're going to go through this first demo over here on my side, which is a demonstration unit that was first shown at the IMTS show here in Chicago last September. We were very excited about this. We got a ton of traction from that show of people wanting to see single pair Ethernet in action. This was a joint venture between the companies that you can see either up on the screen or here on the case. The first one being Spark Fund that built the entire demo unit. The second one being Analog Devices. So, Brian, who just joined us from the panel discussion, was involved in part of the Analog Devices portion of the PHY chips. Harding being at the center, providing the cable that you can actually see. When we zoom in on this, it's wrapped up, but you can see the length of cable running between SPE to SPE. There's no traditional Ethernet that's happening within this demo box. It is only single pair Ethernet to single pair Ethernet connection. And then Verth Electronics for the magnetic chipset, another Industrial Partner Network member that's joined us in previous SPE symposiums, as well as Industrial Ethernet Weeks. And this was all pulled together for the IMTS event by DigiKey. which is another one of our partners. So diving right into the demo unit itself, I want to kind of walk through what we're looking at here. So whether you're looking at the screen here or the live demo unit, there are two development boards that were utilized in this design. And this is actually a functional application use case of a vibration monitor. If you're familiar with industrial automation or process automation, there can be a lot of machine vibration in the market in industrial applications. Sometimes that is not an acceptable thing to have happen. If it's a highly sensitive application, you need to know immediately if machines, piping, or individual sensors are vibrating, and you need to go address that issue. So this was built directly as a response to that, showing that you can monitor that activity via single pair Ethernet. So, we're going to start here just with the vibration monitor starting off, and you're going to see the state change. You can see a change there from green to red showing vibration on one of the two LCD screens. So there's one LCD screen that's here with the QR code about everything that's involved in this demo unit, as well as all these individual components. And there's another LCD screen on the bottom. But what it's showing on that screen is that when it's in the green state, there is no vibration and everything is safe. When it's in the red state, it is detecting vibration via this sensor on the top of the pipe. And someone needs to go out and address that and figure out why that is happening. So again, we were very excited to show this. It further reinforces the fact that SDE is in the development stage and in the early adopter stage. Our customers and the market need to know that, number one, devices are available from the companies that you can see here on the screen, whether they're a component manufacturer or they're a channel partner like both the panelists, Dale's organization, or some of our other channel partners. This technology exists, it's ready, and it's working independently. Again, there's nothing that's going on behind this pillar where it's going back to a RJ45 connector or traditional 8-wire Ethernet. This is a single pair Ethernet connection on a development board going to a single pair Ethernet connection on a development board and doing, what looks like a simple application use case, but this spurred because this is actually a real condition that's happening in, it's an office building, but they need to manage sump pumps and they need to know if that pipe is vibrating where the sump pump is located in the facility. And that's how this specific application use case was formed, was based on that need. And in their location, they're already using single pair Ethernet with these development boards to create that solution. So here's just a closer view. You can see that state change there. So again, a simple application, but it sends the point home that this technology is ready for development. And so the second one is reinforcing that, this specific section here about sensor to sensor communication and sensor to cloud communication. That's the demo that Arnold's going to be walking through. I'm going to show some of the components that are involved in that. This is through another industrial partner network member, PeriNet. Arnold really has spearheaded this application and the day-to-day communication with PeriNet, so I'm going to let him take it away.
Thank you, Mackenzie. So the second application example I would like to share with you using single pair Ethernet is this proximity sensors. As you can see here, I have it on hand. So here's a proximity sensor. It detects an object in front of sensors. You have here the M8 T1 hybrid solution. M8 T1 hybrid solution, you probably saw that before. It's a hybrid SPE solution. You have 4 pins, 2 pins for the single pair Ethernet and 2 pins for the power. So from the single pair, here's the cable here, the hybrid cable, M8 T1, the hybrid cable with the power and the single pair Ethernet. It divided with this junction connection here. Here going to the power, to power the sensors. And here is the RJ45 to have it connected on my computer so we can have it on the browser.
So while Arnold's logging in there, just real quick, I want to talk through what we're looking through on the screen, which is, this is not multi-drop in the traditional sense of single pair Ethernet multi-drop, but this is another version of multi-drop that we can look at on the screen, where it's a daisy chain solution using the PeriNet 1 in, 1 out with the drop application. So in this application that you're looking at here on the screen, you would be able to have one common bus line using single pair Ethernet technology, and it would be dropping down to the individual sensors like the one that Arnold's showing here.
Thank you, McKinsey. So if I put my hand actually in front of the sensors, you will see the signal of the GPIO here second turning on. On, you can see that on. When I remove, it turned to off. I put it back, turn to on. I remove it, turn to off. So two use case example for this. The first one is the conveyor system. So you can have your conveyor system belt. You have a product on the conveyor. The sensor, the proximity sensor, will tell there's an object, and the robot can take the object when the product is close to the sensor. Another application use case could be collision detection. If you have two robots, you have the sensors on the robot, it would detect if the robots are close to one another. So if you need support in your SPA journey, we are here to support you. We are here to help you. And this concludes the second demo. So back to you.
Yeah, and just another quick thing that we haven't touched on of this is that the hybrid use case is especially exciting because it's able to adapt to sensors that are already on the market from either our distribution partners or ones that are available directly from sensor OEMs. That's an off-the-shelf sensor that's been adapted to the T1 Industrial Hybrid -6 connector. And we're able to do that because of these individual components that you see here from PeriNet. So you're able to take a sensor that is on the market today and adapt it to single pair Ethernet to start getting single pair Ethernet into your industrial environments. And really, that's another major factor of the difference of hybrid versus the T1 Industrial is that with hybrid, because of the M8 form factor and with the new -7 being the M12 form factor, it allows you to adapt to products that are available today. And if you're ready to hit the ground running and just get started with SPE, maybe that's your best option. And if you need some custom tailored SPE development, that's where you work with Harding, you work with the Industrial Partner Network, and you work with our ecosystem of partners to develop a bespoke tailored solution for your industrial application. So if you have further questions, we want to address them. Make sure that you get them into the chat right now. We don't have time to go through them in this moment, but someone from Harding will reach back out to you to address those questions. But right now, I want to reintroduce Lucas to close us out of Industrial Ethernet Week.
Thanks, guys. Wow. I want to say a special thank you to the two of you, Arnold and Mackenzie. I know that both of you have been very, very much involved in this from the beginning and have seen this evolution year after year after year. And I think the excitement and the energy is building over where this is going to go and to see applications, real world applications for how the technology is being used. And I highly encourage you, if you are interested and you have been thinking about, well, I think this is a really cool technology, but I'm not sure exactly how I can integrate it into my current designs, please just put a question in the chat. And we have so much experience across a lot of different industries. And the Industrial Partner Network is probably one of the biggest resources that is available today to help that transition, help the thinking from where I'm at today to where I can go into the future. So thank you very much for the two of you for all the time. I also have a thank you to the people that put this event together. What you see on the screen is only a result of all the people that are in the room. There's a whole camera crew, there's all the sound, the mics, all of the slide presentations. All these people are putting forth just a lot of effort, and I thank you so much for everyone, again, in the room to make this happen. For this reason, to help progress this conversation and to move this forward. And that you can see probably from all the people, from the panelists that have joined, from the industry organizations, the engineering fellows, the program managers, the design engineers, all the people that have come to share in this experience and be part of this conversation, you can see that the energy and excitement is palpable. So thank you for being a part of it as well. All the people that are on the phone, the people in the room, the panelists, taking time out to encourage this conversation to move forward as well. With that, Industrial Ethernet Week is a wrap. We thank you so much. All of those that have registered will receive an email link to all of these. And again, we highly, highly encourage you to reach out if you have any questions at all. Thank you so much. And with that, thank you for attending Industrial Ethernet Week.